Okay, let me say a little bit about interactive jobs. So in addition to using sbatch, which will submit what's called a batch or a background job, you can also actually run jobs on the compute nodes interactively, where you're just typing away and you can just sort of see what's happening on the fly. And that's a good way to sort of prototype your code, or if you need to do something where you really need to interact with the system. The same rule applies that you're going to get the entire node, and so if you're doing something interactive where you're not doing it in parallel in some way, you're still getting charged for all of those CPUs, even if you're only using one of them. So let me go back here, and we'll just briefly see what it looks like to run interactively. So, okay, so you would basically execute code that looks like this. And now what we're doing is we're running srun, and we're going to pass those flags that I put in the job script. We're going to pass those flags directly from the command line. So in this case, I'm again going to use the reservation. So I'm going to change this to Savio 3, and I'm going to change this to AC_SCS guest. And I'm going to change it to -- reservation equals Savio 3-testing. So you wouldn't have to put the reservation in. You often wouldn't have to put the account in if you just have one account, or if you want to use your default account. You generally would need the partition, and then if you're doing more than one nodes, you would want to put in the number of nodes. In this case, I don't actually need that, although I could leave it in there. Okay, so the requested reservation is invalid. Was it called something else? Oh, Savio 3-training, not testing. Okay, so you'll notice that my prompt here says that I'm on login node 2. And once I hit this and am allocated a resource, the sort of main clue that you have that you're actually running a job interactively on the compute node is your prompt will change, and it will show you the name of the node that you're running on. So in this case, I'm running on node 0069.savio3. And if I do something like host name, it should actually confirm that that's the node that I'm on. At this point, I can do whatever I want. I can do module load MATLAB or Python. I could run that Python calc.py script that I ran. I could do whatever I want. Okay, so questions? Yes.
So, for instance, if you have a very intensive job and then you check the memory, you're using like a whole node, and then you check the memory and it's what you said, maybe like over 80%. Then that means that probably you should be using 2, even if you're not using parallelization?
No, that's a great question, and I'm glad you asked it. It means that you should either A, try and see if you can somehow reduce the amount of memory your code is using, or B, use one of the big memory nodes, or C, the only time that you can actually take advantage of the memory on multiple nodes is if the code that you're running can actually run on multiple nodes. There's no way to share memory across nodes while you're having a job run on one of the nodes. Yeah, I'm going to get to that in a second. Other questions? So let's go back. I'm going to remind myself where I am here. Same thing on the interactive nodes. You're still charged for the entire node. Are nodes shared? No. So if you're running a job on a node, you get access to the entire node, and nobody else can do anything on that node, which in some ways is good, because that means you're not competing, for example, for memory on the node. In terms of if you do want to run stuff with a graphical interface, we have a visualization node that allows you to do that, and there are ways basically to connect a visualization node to a compute node to run things like Python or RStudio. So there's some information here. That's also something we can help with on a one-on-one basis. The low priority queue, I don't think I'll spend a lot of time on this. I mentioned it before. If you do have access to a condo and you want to run a very large job, or you want to run a job if you want to run a job that uses more nodes than you purchased, or if you want to run on nodes of the type that you didn't purchase, you can run in low priority mode. And this is a good way to run like a very big job that you are willing to wait to have it run. Well, that's sort of a bad way of phrasing it. That you wouldn't mind having the job killed. So you're not going to get charged for that job, but the cost is that the job could be killed and you might have to resubmit it. So if you notice that Savio is not that many nodes are free, you could then decide that's a good time to run a low priority job and hope that it doesn't get killed. And these kinds of jobs are also jobs where you hopefully would want to be able to save your output on an interim basis and restart your job from wherever it got killed. So if you can set up a job to do that, that also would work nicely with the low priority queue. Okay, so let me go back to this question of whether you get access to the entire node or not. So the two partitions which are allocated on a per core basis are Savio 2 HTC and the Savio GPU partitions. And on those ones, you will basically ask for 1 or 2 or 3 or 4 cores, or CPUs, and you would get access to those. So here's an example. This is just an interactive job, but you can do this with SBatch as well. I'm saying I want to use the Savio 2 HTC partition, and then I say I want CPUs per task to be 2. So that means I want to get 2 CPUs that I can then run my code on. So I would ask for 2 CPUs if I had set up my code such that it could use 2 CPUs. If it was just a serial job that would only use 1 core, I would change this to be equals 1 here. So that's a good way if you have jobs that you can't naturally parallelize. You can use these cores. And these are charged per core as well, so you're not going to be charged more than you're using. Same thing basically holds for the GPUs. You would ask for however many GPUs you want, and then we ask that you request twice as many CPUs as the number of GPUs, and then you would be that's what you're then charged for. Okay, any questions there? Okay. Let me say a little bit partly in response to the gentleman's question about what if I have a lot of smaller jobs that maybe each job can only use a single CPU. So the tool that we really recommend there is something called HT Helper, which stands, I think, for High Throughput Helper. And what HT Helper does is you basically give it a list of the computational tasks that you want to run. So maybe you have 1,000 things that you want to compute, and they can each be done independently. And each one of them often would only use 1 core, but each one of them could, if you want, use, say, 2 cores or 3 cores or something like that. What you would then do is you would write some code that uses this HT Helper, and it basically you would write the code to basically tell HT Helper how many of these tasks you need to run and what the code is that needs to get run to actually execute each task. And then you would submit the job. You would write your job script, your Slurm job script, to call HT Helper with the particular invocation that is given in this documentation. And what HT Helper will do is it'll say, oh, you gave me 1,000 things to do, and you started a job where you asked for 2 nodes and, say, 48 cores on Savio 2. So what HT Helper will then do is it'll basically set up a little scheduler inside of the Slurm scheduler, and it will start up 48 of those 1,000 tasks at the start. And when one of those 48 finishes, it'll start the 49th one. And then when the next one finishes, it'll start the 50th one. And it'll just walk its way through all of those 1,000 tasks. And the nice thing that will accomplish is it will keep 48 cores busy until you get to the end of the computation. So you'll effectively be using all of the entire 2 nodes in the example I was giving.
Would that work if one of them are dependent on the other?
No, it wouldn't work if they're dependent on the other. So you really want these to be independent tasks. I suppose that if the tasks were sort of far enough apart that you knew one was going to finish before the other, then it might work. But there's sort of no guarantee of what order, when things will necessarily finish. So generally, you'd want them to be independent.
Question.
Yes.
How does that interact with wall times?
You would want the wall time to be the total wall time for the entire 1,000 tasks.
So determine if you're there, I can't restart it.
I mean, if you wrote output, say suppose you got 500 finished and you wrote the output from the 500, you could just change your code to do the next 500 in the next job. Yeah. There are also lots of ways in tools like Python, R, and MATLAB where you could basically do something a little bit like what I just said, which is you would write your R, Python, or MATLAB code to work in parallel, and that will often work nicely across cores on one node. And there are tools for Python, R, and MATLAB that would allow you to run across multiple nodes as well. So if you're working with those tools, then you can also make use of multiple cores for independent computations. Okay, so let's see. We're running a little low on time here. Let me see what I want to focus on here. We've already sort of covered most of this about sort of checking the status of jobs. This sinfo command is useful because it will show you how many nodes are free on a given partition. So this would give you a sense of whether if you submit something right now, is it likely to start running soon, or does it seem like the system's really busy? So you'll notice here, this is Savio 1. There are 81 nodes that are allocated that are being used right now, and there are 7 that are idle. So this is an indication that there is some free resource on Savio 1 that you could potentially make use of now. The other thing I'll mention is this check usage. So if you're running under an FCA, you have a limit of this 300,000 core hours. And so if you want to know how much of the 300,000 core hours or service units have been used during the year that we're talking about, you can run check usage. And so if I did that, for example, I think a better example is there's an FCA called Geisler that I'll look at. So this takes a little bit of time to sort of do whatever arithmetic it needs to do to sort of compute how much usage has been made over the past since June when the FCAs were reallocated. Okay, this is going a little more slowly than I expected. Okay, so this says that under this FCA there have been 87 jobs run since June 3rd of this year. They've used 21,000 CPU hours, and that's made up 26,000 service units out of the allocation of 300,000. So this particular FCA, they've been doing some computation, but they're not all that close to the limit of what they could use. Okay, any questions there? Okay, so the last thing I'll do is I'll just show you a brief demo of running some parallel code in Python, and then we'll quit. Okay, so I'm going to do sort of something similar to the sorts of things we saw that Christopher was showing. So I'm going to copy bayarea.csv into my Scratch directory, because that's where I want to do data input and output from, is from the Scratch directory. So I'm going to get my input data there. This pip install is just an example of if you want to install your own Python package in your home directory, you can't just use pip install because it would try to install in the system directories, and you don't have access to those directories. But you can use this ---- user flag, and that would then install it in your home directory. And so in this case, it says, oh, stats models is already available, so it's not going to go ahead and install it. But if this were a package that were not already installed, this would be how you would run that. Okay. Oh, actually, I forgot. I was still in my srun session, so I was still getting charged for that session. So if I wanted to get out of that and stop being charged, I would type exit. Okay. So now I'm back on the login node. And so now at this point, let's suppose I wanted to run that Python code in an interactive session. I could do the same thing. Again, I'm going to change this to Savio 3. I'm going to change the account. And I'm going to put the reservation in. So that was equals Savio 3-training. OK, so now I'm back on that same node. And actually, I now have access to 2 nodes. If I did env and I looked for slurm, this gives all the environmental variables in the shell that are being set by slurm. And you'll notice, for example, it says the number of nodes is 2. So that's an indication I have an allocation of two nodes to do my computations on. OK, so at this point, if I'm running Python and I want to run the IPython parallel tool to run across multiple nodes, I basically need to start up Python worker processes on all 2 of the nodes, 1 worker process per core that I have available. So that's basically what this syntax is going to do here. It's going to load the modules I need, and then this IP controller and IP engine are basically going to start up a sort of master controller process and a whole bunch of worker processes. And what srun does in this context, which is different than srun in this context up here, is if I run srun within another srun or srun within an sbatch, it will basically run this command here, whatever comes after the srun. It will run that command on all, basically once for each of the cores that I have access to. So this will start up 48 different Python processes. So I could go ahead and do this. There's a bunch of sleep commands in here because I need to pause and wait for the earlier commands to finish before I start up the later commands. Oops. But it's sort of pausing. I probably actually need to make this sleep for longer to give it enough time. But basically, this is how you would start up all these workers. And once you've started up the workers, you could then start IPython. And then in IPython, there's a whole bunch of code here that just gives a demo of running Python code in parallel. So I think for the sake of time, I won't go through exactly what this is doing. You would need to either you might be familiar with IPython parallel, or you'd need to go sort of look up the documentation and get a sense of how this works. But there's at least a starting example of some code that would work. If I, for example, do ps aux pipe into grep Python, I should see a whole bunch of Python workers running here. So there's a list of a whole bunch of Python processes, and that's an indication that those worker processes have all started up, and I should be able to have access to them. In this case, I'm just going to exit out rather than fully completing the demo here. Okay, so I know that was fairly abbreviated, but are there any questions at a high level about what I was doing there? Okay, I'll just mention a few things just to wrap up here. So one is that there's a nice package in Python called Dask that does a really nice job of managing parallelization across across the cores on one node or across multiple nodes. So I didn't put any documentation in here for Dask, but we did give a training last spring on that, and there's a link to the training here. And I've also prepared a tutorial on using Dask, and that's here. And then there's tons of resources online over and above that. But if you're somebody who uses Python or is interested in getting started on using Python, and you're interested in doing stuff in parallel, I would recommend making use of Dask. The other nice thing about Dask is if you have a very large data set, for example, one that wouldn't fit in memory on one node, sort of going back to your question, you can use Dask to basically operate on a single data object that gets split up across multiple nodes. You'll use the memory of those multiple nodes, and you can also then use multiple CPUs to compute on that very large data set. So Dask makes that fairly easy to do. Okay, so let's wrap up with a little bit of more information about getting help. So if you have a Savio-specific question, how do I do something, this isn't working, something seems wrong on the system, any of those things, just send email to this address, and one of the systems administrators or one of the consultants will respond to that, and we'll try and help you. If you have a more general computing question, for example, BRC, Berkeley Research Computing, can help you get access to not only to Savio, but to resources more broadly on campus or in the cloud or to NSF resources across the country. You can email us at brc@berkeley.edu, and again, one of the consultants will get back to you. We also hold office hours, so you can just drop in if you have questions. And then we also do consulting around data management. If you have, for example, confidential data, health data, educational data that needs to be protected, we can help you with that in terms of how to protect it in terms of storage and also where you can do computations with it. So you can email researchdata@berkeley.edu, and we hold the same office hours both for computing and for data. So you can come for either of those sorts of questions. And then I'll just mention a few things that are coming up. We have an open house and some training on working with secure data, including working with secure data on Savio, which is now possible. And that'll be in about a month here. I think it's going to be here at 3 p.m. on Tuesday. We're usually looking, and we are now looking to hire additional consultants to help people like you. So if you're a graduate student and this sounds interesting to you, we have some flyers in the back, or you could just ask us if you have questions about this. And is Amy back there? Yeah. Amy, I forget the third thing that you wanted me to mention that I didn't get a chance to put on here.
The cloud meetup.
Oh.
So anybody who's interested in cloud technologies, we hold a monthly meetup at the Skydeck, always the fourth Tuesday.
What's the Skydeck? That sounds very futuristic, but people might not know what it is.
It's in downtown Berkeley, and it's where startups start. So you're welcome, and we have pizza there too.
So do we have snacks now, pizza out here? Okay. So are there any questions before we break? Yeah.
Is there Python notebooks remote? Can we access like?
Yeah, there's a slide that I skipped over for the sake of time where you can use Jupyter Hub to access notebooks, or you can go through the visualization node. The visualization node is a little bit more robust in terms of if there's an error, you can sort of see what's happening more easily, but those are the two ways that... If you're just running sort of a low computational burden job, you can just run it on the Jupyter node, and that won't get charged anything. If you're running something in parallel, then you'd run it on a compute node, and you would get charged. Yeah. Any question in the back? You'd use the interactive node if you, for example, wanted to bring up an RStudio session or a graphical interface to a Jupyter notebook or a graphical MATLAB interface, and then be able to like point and click and those sorts of things. So, okay, well, let's break here. A few of us are mingling around. We're happy to answer questions one-on-one, and there's some pizza outside, so please take advantage of that, and we'll be around to just chat if you have questions or thoughts.